Hey everyone, Mr. Hauk here. In our previous video, we established the entire first quadrant of the unit circle. By the end of this video lesson, we should be able to use patterns to establish the remaining quadrants of the unit circle. Let's go ahead and get started. As we explore how we can establish the remaining quadrants of the unit circle, let's consider some symmetry in the xy plane. So we have these 2 points A and B, and what we're going to do is we're going to reflect A and B constantly across the different axes in the xy plane. Let's start with reflecting A and B across the y-axis. So I'm going to reflect A across the y-axis. This is going to give me point C. And notice that the coordinates of point C are going to be -2, +3. And reflecting B across the y-axis, we're going to get point D. And the coordinates of point D are going to be -3, +1. So notice that by reflecting across the y-axis, all that changed was the sign of the x-coordinate. The sign of the y-coordinate stayed exactly the same. Now let's see what happens when we reflect these new points C and D directly across the x-axis. So reflecting point C across the x-axis, we're going to get point E. And the coordinates of point E are going to be -2, -3. And reflecting D across the x-axis, we're going to get point F. And the coordinates here will be -3, -1. Notice that when we reflected C and D across the x-axis, the only thing that changed was the sign of the y-coordinate. Now, one last time, let's reflect our new points E and F. Let's reflect them across the y-axis. I'm reflecting E across the y-axis. We are going to get point G. And the coordinates of point G are going to be +2, -3. And then reflecting point F across the y-axis, we're going to get point H. And the coordinates of point H are +3, -1. So this time, reflecting E and F across the y-axis ended up changing the sign of the x-coordinates, but leaving the sign of the y-coordinates exactly the same. So that's some pretty nice symmetry that we can see here in the xy plane when reflecting points across the x and the y-axis. What I've gone ahead and done is I've applied that to the points that we established in our previous video that are in the first quadrant of the unit circle. So notice, here's our first quadrant of the unit circle in blue. And I've gone ahead and taken those points and I've reflected them first across the y-axis to get the points in green. Then I've taken the points in green, reflected them across the x-axis to get the points in red. And then I've taken the points in red, reflected them across the y-axis once more to get the points in orange. And notice that the signs did exactly the same thing that the signs of the points in the previous example did. So when reflecting from the first quadrant to the second quadrant, the only thing that changed was the sign of the x-coordinate. When reflecting across the x-axis from the second quadrant to the third quadrant, notice all that changed from the second to third quadrant was the sign of the y values. And then finally reflecting across the y-axis again from the third quadrant to the fourth quadrant, notice that our x values changed sign, but the y values did not change sign. Okay, so here, now we have these points all around the unit circle, these very important points, but there's some more properties and patterns that we can establish further. Before we look at more patterns in the unit circle, let's talk about the tangent of theta. So we already know that the tangent of theta is the sine of theta divided by the cosine of theta. But understanding that, what can we determine about the tangent of an angle theta when the cosine of that angle is equal to 0? Well, let's think about that. If the cosine were equal to 0, the cosine of theta were equal to 0, then our denominator would be equal to 0. And we know that we cannot divide by 0. So whenever the cosine of theta equals 0, so when the cosine of theta is equal to 0, we get 0 in the denominator. We can't have that, so that means that the tangent of theta is undefined. And we're going to use that here in just a moment. The tangent of theta is undefined when the cosine of theta is equal to 0. Very important point. So let's think about what we know so far about the unit circle. We know our first quadrant. We know our 30, 45, and 60 degree angles. We know their radian equivalents, and we know the points going all the way around the unit circle. But we don't know anything about the tangents at those points yet, and we also don't know the degree and radian measures of all the other special points on the unit circle. So let's use some patterns to establish some very important and helpful facts. So first off, notice that 30 degrees and pi over 6 radians are the same thing. So every 30 degrees is also every pi over 6 radians. And funny if you notice it, 60 degrees is 30 degrees times 2. And notice that if I took pi over 6 and had 2 pi over 6's, well, 2 pi over 6, if we think about it, would reduce to pi over 3. So every 30 degrees, we're tacking on another pi over 6 radians. So let's see if we can use that to our advantage going around the unit circle here. So we have 30 degrees is 1 pi over 6. 60 degrees is 2 pi over 6, which reduced to 1 pi over 3. And then adding another 30 degrees, we get 90 degrees, which would be 3 pi over 6. And notice that 3 pi over 6 would reduce to pi over 2. And then let's start establishing some real patterns here. So adding another 30 degrees, I would get 120 degrees. And if pi over 2 was 3 pi over 6, well then 120 degrees would be 4 pi over 6. But if we think about reducing 4 pi over 6, that would be 2 pi over 3. So 120 degrees would be 2 pi over 3 radians. So we'll put 2 pi over 3 radians right there. If I added another 30 degrees, I would get to 150 degrees. Notice I'm leaving this one here in the middle blank. We'll get to that in a moment. So we have 150 degrees. And we'll remember that 2 pi over 3, that was 4 pi over 6. So another 30 degrees means another pi over 6. So we go from 4 pi over 6 to 5 pi over 6, which cannot reduce. So we'll go ahead and put that there, 5 pi over 6. If I added another 30 degrees, we'll notice that would be 180 degrees. And if I added another pi over 6, well, 5 pi over 6 would turn into 6 pi over 6. But notice the 6's would cancel. That would leave us with just pi. So we have 180 degrees is equal to pi radians. If I added another 30 degrees, we would get to 210 degrees. And let's just go ahead and finish off the degrees at least. So 210 degrees would correlate to 240 degrees. If I added another 30 degrees, we would get to 270 degrees. Adding 30 degrees again, we would get to 300 degrees. And then adding 30 degrees once more, we'd get to 330 degrees. And making the full lap around the unit circle, we would end where we began with 360 degrees. So now, one more time, just to really establish the pattern here, let's look at those radians again. So 30 degrees was 1 pi over 6. 60 degrees was 2 pi over 6, which reduced to pi over 3. 90 degrees was 3 pi over 6, which reduced to pi over 2. 120 degrees was 4 pi over 6, which reduced to 2 pi over 3. 150 degrees was 5 pi over 6, which didn't reduce. 180 degrees was 6 pi over 6, which reduced to just pi. So then 210 degrees would be 7 pi over 6, which is not going to reduce, so let's go ahead and lock that in. 7 pi over 6. So then 240 degrees would be 8 pi over 6. Well, if we think about 8 pi over 6, that's going to reduce to 4 pi over 3. Okay. Then 270 degrees would be 9 pi over 6. And if we think about 9 and 6, that's going to reduce to 3 pi over 2. Let's go ahead and lock that in. 3 pi over 2. Okay, then we'd get 10 pi over 6 at 300 degrees, but 10 pi over 6, that's going to reduce to 5 pi over 3. And then lastly, 330 degrees, that would be 11 pi over 6 for the radians, which is not going to reduce, so we'll lock that in, 11 pi over 6. So once more, every 30 degrees was 1 pi over 6. So every time we went an extra 30 degrees, we just increased it by 1 pi over 6. We can do something similar here for the 45 degrees. So notice that every 45 degrees is 1 pi over 4. Well, let's go ahead and finish off the remaining blanks in the unit circle in terms of degrees and radians. So 45 degrees, pi over 4. Add another 45 degrees, we get to 90 degrees. If I added another 45 degrees, we would get to 135 degrees. If I added another 45 degrees, we'd get to 180. If I added another 45 degrees, we'd get to 225 degrees. If I added another 45 degrees, we'd get to 270. If I added another 45 degrees, we'd get to 315 degrees. And then lastly, if I added another 45 degrees, we'd go full circle and wind up at 360 degrees. So now let's see what it looks like in radians rather than degrees. So 45 degrees is 1 pi over 4. Then if I added another 45 degrees, we'd have 2 pi over 4, which notice reduces to pi over 2. Then if I added another 45 degrees, we would have 3 pi over 4. Oh, let me get back to that. Notes. Right there. Sorry about that. So adding another 45 degrees, we would get to 3 pi over 4. That doesn't reduce. Let's go ahead and lock that in. 3 pi over 4. Adding another 45 degrees, we get to 180, so that'd be 4 pi over 4, which notice reduces to just pi. Okay, then we're going to get 5 pi over 4 at the next 45 degree angle. 5 pi over 4 does not reduce, so let's go ahead and lock that in, 5 pi over 4. Then we're going to go another 45 degrees, this would be 6 pi over 4. Well, that'd be 3 pi over 2, which we already knew because we did the 30 degree increments. And then lastly, 315 degrees, that'd be 7 pi over 4. That's not going to reduce, so let's go ahead and lock that in, 7 pi over 4. And then once again, just showing the full rotation, another 45 degrees would bring us to 360 degrees. That would be 8 pi over 4, which would reduce to 2 pi. Okay, so a lot of good symmetry there. So just to kind of recap that again, since this stuff is so important, 30 degrees, every 30 degrees was pi over 6 radians, and every 45 degrees was 1 pi over 4 radians. And we did increments of 30 degrees and 45 degrees and increments of pi over 6 and pi over 4 until we made it all the way around the unit circle. But now let's talk about the tangents of each one of these points. So that's what these open boxes are going to represent, the tangents. So remember that, we just previously spoke about the tangent of theta is equal to the sine of theta divided by the cosine of theta. And remember that sine of theta is the y-coordinate, cosine of theta is the x-coordinate. So if I wanted to find the tangent of each one of these points, I would take the y-coordinate and divide it by the x-coordinate. So let's try that here in the first quadrant. So if I did, and we'll do this in a different color here, we'll work in purple just to kind of make it stand out a little bit. Let's say that we did the tangent of 30 degrees first. So we would do the sine, which is 1/2, divided by the cosine of 30 degrees, which is square root of 3 over 2. Well, we have a fraction divided by a fraction, so that'd be 1/2 times 2 over square root of 3. Notice that the 2's will cancel. We get 1 over square root of 3. but we really don't like square roots in the denominator. So we're going to rationalize the denominator by multiplying both the numerator and the denominator by the square root of 3. So notice this gives us, well, 1 times the square root of 3, that's the square root of 3. Square root of 3 times the square root of 3, that would just be 3. So the tangent of 30 degrees is square root of 3 divided by 3. Okay, so that's that little piece right there. Now if we try to do the same thing with the 45-degree angle, so the tangent of 45 degrees, well, square root of 2 over 2 divided by itself, square root of 2 over 2, well, anything divided by itself is 1, so here the tangent would simply be 1. And then lastly, the tangent of 60 degrees, well, we would be doing the y value, square root of 3 over 2, divided by the x value, 1/2. This would lead us to square root of 3 over 2 times 2 over 1. And notice that in this case, the 2's would cancel each other out, and all that we would have left is the square root of 3. So the tangent of 60 degrees would be the square root of 3. Okay? So if I continue, we're going to continue to work our way around the circle, but we're going to use some patterns to help us fill this out instead of doing the division, the sine of theta divided by cosine of theta. That's a little tedious. We're going to use some patterns to establish the rest of the tangent values. But first, so let's move on to 90 degrees. Notice that, we spoke about previously, if the cosine is 0, then the tangent would end up being undefined. This is because we end up dividing by 0. So the tangent of 90 degrees, or pi over 2, is undefined. Okay? Now, we could continue to work our way around the unit circle and divide, take the sine of theta, divide it by the cosine of theta, do all that work. But let's be smart about this. Notice that the coordinates are really the same all the way around the unit circle, except for the signs. So, if we looked at quadrant 1, well, quadrant 1 is all positive x's, all positive y's. So this is quadrant 1. If I looked at quadrant 2, well, quadrant 2 is all negative x's and positive y's. If I looked at quadrant 3, this is all negative x's and negative y's. And if I looked at quadrant 4, it's all positive x's and negative y's. And let's use that to our advantage here. So if I'm trying to find the tangent of 120 degrees, well, we already know we're going to take square root of 3 over 2 divided by negative 1/2, but we've already done the math over here. We already know square root of 3 over 2 divided by 1/2 is going to be square root of 3. But if I'm going to take a positive and divide it by a negative, I know my answer, my tangent, is going to be negative, and then we've already done the math, we've already done the algebra, we know we're going to get square root of 3. So we're going to get negative square root of 3. Same deal here, if I take a square root of 2 over 2 divided by a negative square root of 2 over 2, well, we've already done the algebra, we already know it's going to be 1, but because we're dividing a positive by a negative, we're going to get a negative tangent value. And then similarly here for 150 degrees, we already know that 1/2 divided by square root of 3 over 2 is square root of 3 over 3. We already did that algebra. But again, we're dividing a positive by a negative number, so we know we're going to get a negative tangent value here. All right, continuing to work our way around, so now we get to pi. So first off, we know that this coordinate right here is going to be -1 and 0. And if I divide 0 by -1, I'm just going to get 0 for my tangent value. So now let's move into the third quadrant. So here in our third quadrant, again, let's just establish some patterns here. We've already done the algebra for 1/2 divided by the square root of 3 over 2. We already know that that's going to be root 3 over 3. Square root of 3 over 3. Now let's just talk about the sign. Well, since we're dividing a negative by a negative, that means all the tangents here in the third quadrant are going to be positive. So we already know that, this is going to be a positive 1, and we know that this will be a positive square root of 3. Again, we've already done the algebra. We're just trying to figure out the signs now. Over here in quadrant 4, we know that, square root of 3 over 2 divided by 1/2 is going to give us a square root of 3. But since we're dividing a negative y value by a positive x value, we're going to get a negative. Here we'll get a negative 1, and here we'll get a negative square root of 3 over 3. So if we're looking at we forgot 270 degrees. So looking at our 270 degree angle, we know that the coordinate is 0, negative 1. We know that the cosine of 270 degrees is 0, so we know that our tangent's going to end up being undefined because we're dividing by 0. All right. So let's look at those tangent values again. So for all the points in the first quadrant, since both the x-coordinate and the y-coordinate were positive, all the tangent values are positive. So I'm going to write here, just as a little reminder. So tangent of theta is positive. Over in the second quadrant, we know that because all the x values are negative and all the y values are positive, that all the tangent values are going to be negative. So here in the second quadrant, tangent of theta is negative. In the third quadrant, since all the x values and all the y values are negative, negative divided by negative is going to give us all positive tangent values. So tangent of theta, positive. And then lastly, in the fourth quadrant, all positive x values, all negative y values, so all the tangent values are going to be negative. And that really completes our unit circle. We have, so just to kind of recap it here, we have all of our degree measures, we have all of our radian measures, we have all of our points and all of our tangents, and we establish them all the way around the unit circle using symmetry. And then one last little thing that I forgot to put in here, the tangent at 0 degrees, which is also the tangent at 360 degrees, is going to be 0. All right.